Hi everyone, this is Sadiq Iqbal, and today I'm gonna present a 6G white paper, which includes research challenges for trust, security, and privacy issues that 6G is going to face in the coming years. So this presentation is going to include multiple videos. So please bear in mind and please watch the whole video lectures. Okay, so let's start. The presentation is going to include four main topics, and there are main topics that are related to trust, physical layer security, and privacy protection. And the trust networking, network security architecture, and cryptography technologies, and physical layer security solutions and technologies, and privacy protection. These three are mainly different parts of the architecture that will be incorporated and will be 6G is going to be based on related to in terms of trust, in terms of physical layer security and network security, and in terms of privacy protection. Okay, the first part is related to trust networking. First of all, let's first define what is trust. We already know networking means. What does networking mean? If every one of you who are listening to this lecture are from computer science background or networking, or have taken a course related to computer or networking. So, some of you may not know what trust in terms of networking is. Trust is basically is a type of conviction, is a type of an understanding between two parties. Let's say a provider and a consumer. Provider, it can be a network provider, a carrier provider, it can be uh, internet service provider, it can be a company who is providing internet services, a company or a business or an organization or a government party. uh, there is a trust, there's a mutual understanding that whatever data is whatever service the provider, the other party is providing is trustable. There are no issues, there are no uh, the data, the service, the internet connection that the other party is providing is not hijacked, is not malicious, and it's not been spoofed. And in this way, the consumer has his trust, put his trust that the service provider, what kind of product or service or internet connection is or the data is the other providers providing as a terms of in a product is legitimate, and it's not been uh, tampered with. So trust is in a network is about the expected outcomes of communicating with a remote party in a session when clicking on a link or believing in what an email says. So just like I said, that it is an expected outcome of, if for example, if we click on a link, that means if the if the click is related to, if the given link is related to some type of product or some type of a service, or is the link related to an or website which is offering is for example, let's say a key e-commerce website. So if there can be on the internet, there are many types of links available for the marketing, affiliate marketing, and others link as well, and some are hijacked, or some are spoofed, or some are used for clickbaiting. So trust networking, in terms of trust networking, there is an expected outcome that if a user clicks on the link, that he is believing that whatever the link is saying is that is 100% legit, and that is what the after clicking the link, the outcome is going to be as expected. So the possible outcomes are either positive value of communication, or being hacked or cheated in some way. So these three are the possible outcomes, and what trust networking usually cares about is the positive value of communication, and this is all that matters. Okay, and in trust networking, trust spans all protocol layers from IP, Internet Protocol layer, to application and content. So it doesn't matter at what part of a network we are talking about, or we are in. The trust spans all the protocol layers, and even I think it spans to physical layer as well. Because if for example, let's say if a network provider, for example, we use 4G. If, let's take this as an example. If the if the 4G service provider is using latest technology, and he is encoding and encoding the transmission, what the transform is encoding the data when it's transmitted in by using the state of the art, and is able to provide trustworthy internet connection. And it can be the internet connection, or VoIP call, or messaging, instant messaging. If the internet provider is able to accurately provide protection, accurately provide legitimate data to the end user, then there is a trust build. So and in it's also protected against attacks that are actually related to physical layer. And that can involve eavesdropping, jamming, spoofing, and uh, man in the middle attacks. And there are other attacks as well that can happen in physical layer as well. So trust includes all the scenarios a network or a user might experience. Yes. So as I explained, from the for example, let's take this what I'm right now recording the video. This is the content, but if I send, this is the starting point of the creation of the content, and after that, if I send this to let's say you guys, if you after I upload this to a hosting service or a website where you can get this data, or in any type of format. Let's assume that it's in video format, and as it is as a course. So you guys will be the end user. So there's a very complicated task procedure from procedure taking place from my end to the your end. So in this whole procedure, it just includes all the scenarios. So you have to take this in mind as well. So ITU TY3052 and Y3053 virtual network, and the SDN trust framework, software defined network trust framework, and the customer edge switching. These are all state of the art systems, but CES is advanced, and it supports personalized security policies for all devices, and at the extreme turns the network into a firewall. So here, the customer edge switching. This is a state of the art, and in terms of the previous ones, this is the more advanced, and it can actually provide security policies, personalized security policies, to and turn a network into a firewall. From the example on the left side, you can actually see that in terms of the two vertical walls that are depicted as firewalls. So between the interconnection, private domains and the public domains. So this is actually going to be incorporated into the CT as well, and it is expected. But let's see what will happen. In the 5G era, national security concerns are playing an increasing role in mobile technology. This trend will be even more prominent in 6G. So to address these concerns, 6G networks must support embedded trust. This is a prerequisite, and so that the resulting level of information security in 6G and the packet data networks to which 6G provides connectivity is significantly better than the state-of-the-art networks commonly used today. So this is the situation is going to be uh, the foundation is going to be the same as the 5G, but there are going to be extreme care, new improvements, modifications, and uh, other involvements as well in terms of providing security, in terms of providing a state of the art protection against and the trust issues as well in 6G. And if these are not included, then 6G will not be able to provide what is expected of 6G. So this is for this video, guys. Be sure to watch the next video for the coming slides. Thank you.